Good day everybody. Today we will learn about expansion joints in pipe stress analysis. Here in this system you can see that in each leg there is one expansion joint used, and this is a tied type expansion joint. As you can see that it is tied, and here also in this leg also there is one expansion joint used. So in each leg mostly it will be connected to a pump or some critical equipment. So as the providing loop or other means conventional means which is difficult to use, so during those situations expansion joints are used. In general it is not allowed to use expansion joints in a system because first of all their life may not be that much, similar to 20 years or something. After a certain cycle period of cycle you have to replace the expansion joints, and every time you have to purchase a spare, and those are costly items as well. So because of these reasons, in general normal systems does not employ expansion joints or expansion bellows. And also note that in some organizations expansion joints are synonymously used as expansion bellows, but basically bellow is one element of the expansion joint. But still in some organizations you may be hearing that expansion joints are called as expansion bellows. So don't get confused, both are basically same, but to be specific, bellow is a part of the complete expansion joint assembly. So before proceeding into the further details of the expansion joint, let's start with that when these expansion joints are installed in a piping system. When do we need to install those? But before that, let's learn what is an expansion joint. We all know that expansion joints are mechanical devices that absorb thermal movement. That means the complete assembly of expansion joint consists of all the elements which are mechanical, and those creates a system which absorbs thermal movement. It may be thermal compression or thermal expansion. In general, when there is a thermal expansion in a piping system from installation to operating temperature, means let's assume that installation temperature is 21 degrees centigrade and operating temperature is 150 degrees centigrade. So during that time thermal movement or thermal growth is happening, expansion is happening, and during that time the expansion joints gets compressed, and when it is thermal compression means operating temperature is less than the installation temperature, during that time the expansion joint gets expanded, and in both cases they absorb the thermal movement, and it consists of one or more metallic or non-metallic bellows. These are the elements you see in this drawing or in this image, that convoluted parts. These are known as expansion bellows or bellow elements. As the work or activity of absorbing the thermal movement is taken care by these bellow elements in different organizations, sometimes expansion joints are known as expansion bellows also. So don't get confused, means if they are telling about the expansion bellow, they are actually basically telling the complete assembly of expansion joint only. So in general, expansion bellows or expansion joints are not recommended in any piping system, that I was explaining in my first slide. But sometimes the expansion bellows are employed in a piping system in one of the following situations. So what are those situations? First is less space. So when the space constraint do not permit providing adequate flexibility by conventional methods for maintaining the system stresses within acceptable limits. By conventional methods, normally in general what we believe or we understand is providing expansion loops. So by providing expansion loops when we are not able to mitigate this, or where there is a less there is not possible to provide expansion loop, because we know that expansion loops takes a huge space. So when that is not feasible, during those situations we can use expansion joints. For an example, you can see here that this is a pump connected system. In general, this type of routings are performed for water piping system. So these pumps and also the size of these pipes are very high, normally 40 inch and more, 42 inch, 48 inch. So this type of sizes. And if you have to provide a expansion loop to qualify the pump nozzles, then it will take a huge space, and that is normally not available during this type of routing situations. So in general, for this type of situations, we can go for expansion joints. Here you see that discharge as well as pump suction, in both cases they have used expansion joints without providing any expansion loops. And this type of systems easily qualify the uh, equipment nozzle loads also. So which is will be coming for the third part, equipment qualification. So let's go to the second point. So when conventional solutions create unacceptable process conditions, for example, when you are employing one expansion loop, so due to that loop length there will be a pressure drop also. So if process condition does not permit that excessive pressure drop, so during that time also we can go for expansion joints. Third is equipment qualification. So when it is not practical to limit the piping induced loads on the equipment terminal nozzle points of the connected equipment within admissible limits by conventional methods. So as I was explaining, that when it is not possible by using conventional methods to qualify the nozzles, during that time also we can go for expansion joints. And finally, lastly, for high critical systems connected to turbines, compressor, or any other equipments, sensitive equipments basically, and for turbine connected systems, temperature also will be very high. Mostly it will be more than 450 degrees centigrade temperature. So in those situations, a huge thermal load will be uh, applicable at the nozzles. So to qualify those type of nozzles, we need to use expansion joint. So when equipment such as compressors, turbine pumps, etc. necessitates isolating the mechanical vibration from being transferred to the connecting equipment. So first point is that we are safeguarding the nozzle from the nozzle load transfer from the piping system, and also it is sometimes required to isolate both systems. Means there is a compression or there is a vibration in the compressor side or turbine side, and we don't want to transfer that vibration to our piping system. So during that time this expansion joints acts as a isolator for that vibration. So in those situations also expansion joints are used or employed. And here in this diagram you can see that there are various types of expansion joints which we will be studying later. Just for sake of understanding, you can see these types of expansion joints, that there are various types of expansion joints. So one by one we will be learning these types in future slides. Next, why install piping expansion joints? So what is the need that we have to install piping expansion joints? So piping expansion joints or expansion bellows are highly engineered mechanical devices containing one or more metallic or rubber bellows. So as I was explaining in the last slide, so these are the mechanical devices, but those are highly engineered mechanical devices, and each expansion joint will be having at least one metallic or rubber bellow. So the bellow element can be rubber or can be metallic. So depending on the service condition basically. Now expansion joints are used to absorb dimensional changes caused by thermal expansion or contraction of the piping or pipeline system, duct or vessel while containing the system pressure. The system pressure will be contained within the system itself, but at the same time it will allow to absorb expansion or contraction of the piping or pipeline system. The flexible element of the expansion joint that expands or contracts to absorb thermal movement is known as bellow element or bellows. It consists of one or more convolutions. Expansion joints are successfully used in refineries, chemical and petrochemical plants, cryogenic plants, nuclear power plants, automotive, aerospace and heating and cooling systems. So the main reasons for which the expansion joints are used in piping systems are to absorb movement. So thermal expansion as well as compression. It may be expansion or compression, both it can absorb. Then to relieve system stress and strain. So in some time or in some systems you may be finding that by adding an expansion joint you can easily qualify a system from thermal stress also without providing any expansion loop. So those type of situations also expansion joint can be used. Then to reduce mechanical noise and vibration, as I was explaining in the last slide, that expansion joints are used for helping in reducing vibration or noise. So if one pump or compressor is vibrating and if we are using an expansion joint, so it will not transfer to the piping system. So that expansion joint will act as a separating device. Then to have a compact design, this was also explained in last slide, that because when there is no possibility to provide expansion loop due to space limitations, so it helps in a compact design. Then to compensate for misalignment, when there are slight misalignments with equipment nozzle and piping connection or piping flange, during that time also expansion joint can be used if the misalignment is within a certain limit. Then to eliminate electrolysis between dissimilar metals. We all know that corrosion is a very bad factor in oil and gas industry. So to avoid corrosion between that dissimilar materials, sometimes we can use expansion joints. Then to reduce piping loads on equipment nozzles for nozzle load qualification, that also I explained already in the last slide. So now you know that when or why to install the piping expansion joints in piping systems. So these are some of the reasons. There could be some other reasons also, but these are the main or major reasons because of which we will be installing expansion joints in a piping system. Now components of an expansion joint. So as I was telling, that bellow is the main component. You see, this is the bellow. This is the main or major component of an expansion joint, which takes care of that thermal movement or which helps in absorbing the thermal movement, and this is the bellow element. There are some other elements also which are required in every expansion joints. Those are tie rods. Tie rods are or tie rods will be there for the tied expansion bellows. It may be tied, it may not be tied. So depending on your specific requirement, tie rods will be used, and specifically tie rods are used to absorb the pressure thrust of the system. That pressure thrust will be explained later. Then other elements are flanges, because you have to connect the expansion bellow to the piping side. So it could be welded also, but in general flanges or flanged connections are preferred. Then shipping bar, protective cover and internal liner. Normally these expansion bellow elements will not be visible from outside. It will be covered by a protective cover and internal liner, so that the fluid directly does not come in touch with the bellow elements or bellow materials. Then sometimes special elements will be required, like pantographic linkages, etc. So those terms also we will be explaining in future slides. So that's all for this introduction module. Here you can see that in one scissor to plot is attached here. Here all these convoluted parts that you can see 1, 2, then here also one, here also one, here also one. So all these are expansion joints, axial type without any tie rod. So these are used for this. This is actually basically a duct analysis. This is of huge size. Mostly, if I remember correctly, it is 60-inch duct. So by providing loop or something, it will be huge costly item, as well as space limitation is there, because 60-inch, so using elbows and others, so how much space it will be required. So in place of that, the analyst has used expansion joints to qualify all these things. And this is a PSV outlet, it is getting connected here, and here also one expansion joint is used. So this way expansion joints can be modeled as well as used in your softwares, whatever you are using, scissor 2 or autopipe or startprof. And during analysis you will get the results based on your input properties. And in general, all the data whatever is required, you have to find from some catalog, those who manufactures these expansion joints. From those catalogs you have to enter the data in the software so that it gives you proper result. That's all for this introduction module. Thank you.